we're not going to run out of it, even if we scale the total amount of energy consumption on this planet by a factor of 100. And it's super cheap. It's in all countries of the world. And then, of course, we were wondering, okay, maybe that's great that there's another material called thorium and you can use that, but we don't quite have the reactors that the old classical nuclear reactors cannot really run on thorium, or at least the way it works, it's not economically viable compared to uranium. So that was not a good solution. But fortunately, there was a guy called Alvin Weinberg many, many years ago. He had his prime time in the 50s and 60s. He already discovered back then that you can use something called a molten salt reactor that he helped invent. And if you use that type of reactor, then thorium becomes really valuable and you can burn thorium in an economically viable way. And when we started looking at that, in the beginning we were a little bit unsure, is it really true that it works? But it's definitely true. I mean, and so we need to build these reactors and this fuel production that is different from the classical nuclear reactors. But once we do that, the price can come down and we can mass manufacture it. And, we can easily make 10 times or maybe 20 or 30 times more energy than what we are consuming today, and still at a lower cost than all the energy sources we've been using so far. And this is what is exciting, and that's what we are bringing to the table. And then you might ask, okay, so if Copenhagen Atomics or some other company are successful with thorium molten salt reactors, are fusion ever going to be a thing? I don't know. I mean, I definitely think, it'll take many, many years before we outcompete all the other all the other energy forms. And there will, even in 2050 or 2075 or whatever, there will still be some countries who do not use nuclear energy. But of course, all the big countries like USA, India, China, they already use nuclear energy, and they're all very interested in this technology. And I think they are going to use it in very large scale in the next 5 or 10 years. And then after, on the backside of that, of course, more and more countries will do the same. But it will take a couple of decades before many countries are using thorium energy. But hey, I think when we get to the year 2100, so 75 years from now, I think more than half of all energy in the whole world is going to come from thorium.
Yeah, amazing. Are you with me,
Yes,
Thomas?
sorry,
Or is it frozen?
maybe there was a break in the video.
Okay, no, fantastic. We can sort that out. Yeah, you're so right. I mean, the last 3 months, I've personally witnessed how much this prospect of this new way of doing nuclear energy from the likes of Copenhagen Atomics has become such a reality. Even Trump has come out and he has all these new executive orders to fast track the development of all these new reactors. He flew a new reactor from Valor Atomics into on his military plane for using for military operations on military sites. It's here, and investments are already going through for reactors. All these big companies like Oracle's already making decisions. They know that nuclear is the way to go for baseload energy, for being independent, for customizing the energy needs that they have. We already know that energy prices just keep going up and up and up. They're becoming less and less affordable. And it's looking like in the 2030s we're going to have more of a shortfall, really, and there is going to be this new reality of, look at these guys, Copenhagen Atomics, and the incredible work that they're doing, and the reactors that they have and how they operate it. I'm very excited. I'm very excited for the future, because I think the future vision, and you talk about 2100, I think the future vision for me is, we want energy and everything to be abundant, accessible, and affordable for everybody. I think that's where it becomes exciting, that we can go 10x, 20x with everything. And so, for investors and customers watching this show, give us a little bit about the 2030s. What does that look like for Copenhagen Atomics? I know you have a criticality coming, in terms of, the energy that you can supply. What does that look like for revenue for your business, the growth for your business? Give us a snapshot of that.
Yes, of course. You're absolutely correct. So right now we're working on getting the first demonstration reactor or test reactor up and running in 2028. But we're also working with potential customers to start submitting the licenses, because it takes many years under the current regime to get a license to operate a nuclear reactor in any country. Takes many years. So we need to start now submitting these licenses with the authorities in several different countries. So we're doing that with the commercial customers. I mean, they're not customers yet because they haven't paid, but they are potential customers. And so we're doing that. We are submitting these different applications and working on that in several different countries. And I expect that one of these first customers will get the license to operate a nuclear reactor in 2030 or 2031. And then we need to be ready to supply the reactor and the fuel by then. But it's not actually the technical challenges that are going to be the shortest path or difficult path. It is these licenses and approvals. And we are very excited that both US and India and also China are trying to make the time it takes to apply for a license shorter. And here in Europe, they're not yet making it shorter, but they have actually started talking about it. So hopefully also in a couple of years, they will try to make the approval process shorter. Because in the past, if you look at all the reactors that have been built in the past, it has taken 10 years or more to, from the time you decide that you want to build a nuclear power plant at a certain location, then you need to get the site approved, and you need to get environmental studies, and you need to raise the financing to start building the site. Then you can buy the piece of land, and then you can start submitting the real license, the building permit, and the operational license and so on. And that whole process, and then eventually building it and getting it up and running, that whole process usually takes 10 years or more. In Europe, unfortunately, lately it has taken more than 10 years, significantly more than 10 years. But I think in most countries it's still possible to do it in 10 years. But that's what, for example, USA is trying to shorten down to hopefully 5 years or less. And I think it's doable, and I think this is what we will see in the early 2030s, that more and more countries will be able to do it in 5 years. I think sort of in the long term, if we look beyond 2040, I think we will have what is called a type license, which means a little bit similar to airplanes, that as soon as one type of airplanes have been licensed, then you can use that airplane in many countries or almost all countries of the world. And I think we will have something similar with nuclear reactors eventually, that they will be type licensed. But I also think it's too early. It will be sometime in the 2040s. But then once that regime starts to kick in, then we can install them much, much faster, like in 12 months.
Yes. Yeah, well, I think that's the holy grail of Copenhagen Atomics. You want to get to that point where you're pumping these out every day. I mean, one of my favorite manufacturing product is the Raptor engine of the spaceship rocket, and they are producing one a day. It's amazing what they've got to that criticality. So I think that's the amazing thing about the difference between Copenhagen Atomics and the old reactors, is that you can get to 2040, and that's just around the corner. 2040.
Yeah, it's not far
That's
away.
very around the corner. Yeah. And we will be pumping these out, and it's the next era of human civilization. So let's get into your reactor. I want to learn your reactor because it's exciting. It looks amazing. The container, the design of it, the pictures are amazing. The tests you're doing are very exciting to track and see the progress. Paint a picture of your reactor. It's container size, thorium molten salt. Talk to us about waste burning, how much energy it produces.